Welcome to LIS 754 Systems Analysis and Design, and in this section we are going to have an overview of process modeling. A process is a series of steps, a set of actions that we take in order to do something, to achieve a particular end. There's a number of words that we can use synonymously with that: procedure, operation, activity, job, task. Those all have similar meanings. For our purposes today, we're going to use the word process to talk about these series of steps. And we know we run simple processes through our lives all the time. When we shampoo, this is a joke, right, that we use all the time. Wash, rinse, repeat, a simple set of instructions, a simple process, 3 steps. We can have a simple process for getting out of bed in the morning. We have the alarm will ring, we hit snooze, we repeat that as necessary. Eventually we decide to get up, we turn off the alarm, and we get out of bed. When we think about these simple processes, even a simple process like getting out of the bed, we've got a number of steps. Shampooing is a set of 3, but we could start quickly getting into very long lists of these processes. And so one way that we like to think about processes in general is through a flow chart. And so this is a simple process flow chart of our process of getting out of bed. The alarm rings. Are we ready to get up? We are not ready to get up. We hit the snooze. We have the delay of, my alarm clock is for 9 minutes. Yours might be somewhat different. 9 minutes later, the alarm rings. We go through this little cycle here, this little loop. Eventually, we're ready to get up, or we feel the necessity to get up. The answer is yes. Are we ready? And we climb out of bed. The end. So this is a way that we can more clearly communicate the steps of a process. Here's another example. The lamp doesn't work. Is the lamp plugged in? No, we plug it in. If the lamp is plugged in, we check for the bulb to be burned out. If it is burned out, we replace the bulb. If it is not burned out, we get a new lamp. Well, maybe we'll get a new bulb. Well, no, I mean, if the bulb is not burned out, we have to figure out what's going on. So there might be other steps to do. We can see that this is a really effective communication tool. In very few words, we are able to clearly delineate a set of decisions that have to be made and actions that are made based on those decisions. So this idea of a flow chart, of charting the processes in our systems, whether they're thought processes, people processes, we can see that this is an effective way to communicate what is going on through this flow charting process. When we think of processes in systems, we often think of it as the set of a program or multiple programs that work together running in a computer. In computer science, that's what we think of as a process, an instance of a set of programs that are running. And a process is started either by a user who makes some kind of an action or by another program. A process generally uses a specific set of data as input and generally produces some kind of revised or new data as output. So we have, as we talked about before in our systems theory, input, process, output. We're really talking about this process in the middle. And processes can exchange information through different types of communication protocols. So when we are charting our processes, when we are developing what kind of processes our systems are going to use, we have to consider how we are instigating these processes, what data is going to go in, what data is going to go out, and how processes are going to work together, and what data needs to be shared between different processes. So how do we think about this? How do we do this? Well, we can think about it that there are multiple types of processes. And so the first thing we want to do when we're thinking about our systems is what kind of processes are we going to have? We're going to have interactive processes. This is one that a user starts the process. So they can start the process by going to a website. They can start the process by clicking on a link. They can start the process by bringing up a software package that's on their PC. And the user and the system interact. The user contributes some data, the computer responds. The user responds to prompts, data happens, a conversation or an interactive session between the user and the computer happens. And we call this kind of an interactive process, generally is called an online process. Makes sense. There is another kind of process that many of us see the results of, but we're not particularly familiar with, is an offline process called batch, which happens in the background. People don't interact with it. It just is set up and it automatically runs. And since we're more familiar with the interactive one, I'm going to spend a little bit of time talking about what we mean when we talk about a batch process. So this is an execution of one or more programs on a computer without manual intervention. It's generally triggered either by time. So at many places, batch jobs start at midnight or 8 o'clock or some time. The clock happens and then a process gets executed. Sometimes it happens through a count. The system is keeping track of things that are going on in the system, and when there's 100 of these kinds of requests, a process kicks off. Or some kind of an activity happens that triggers another activity. A batch process works on a set of data, of inputs. That's why it's called a batch. It's a batch of data that gets processed. So if you're doing something at an insurance company and or a magazine subscription company, anything that's got a postcard where people filled out data, and you get a postcard with data on it, people will batch up 1,000 of those. Somebody will do the data entry, and at some point 1,000 of those will happen, and off a process will happen, or some other set of information that gets put together. And the work the process keeps running until till that set is complete. All the work on that set of data is complete. And there's lots of examples of this. So almost all billing is done in a batch process. And that's generally a process gets triggered by time. And there's the first step in the process is that the system goes and figures out all of the customers whose billing date is today. So it gets a file, it goes and reads all the billing dates, it comes up with a list of these, of all the people who are going to get their bills generated tonight, and then it calculates the bills. It figures out how much money is due, it gets the name and addresses, it formats it, it prints it, etc. Accounting and financial balances often run this way. So if you want to know all the money that's come into the bank through deposits in a 24-hour period, that's often run in a batch. All the checks that were processed gets run in a batch process. Things in insurance companies like premium billed but not due, all those kinds of financial processes are generally run on an overnight basis. Anything that generates reports is almost always run in a batch process. So if you, in a school situation, if the principal wants to know who what the counts are for the day, students in, students who missed the entire day, students who missed a period. Those things are generally run in a batch cycle. Reports on circulation statistics for libraries over this month, how many books were circulated, what were the most popular titles, or what were the most popular genres of materials. All those kinds of processes, all those kinds of reports are run as a background batch process. So let's think about what an example of a business process would be. I mean, we talked a little bit about some of those, but this is one for an order fulfillment process. And at the highest level, so a subscription company or Amazon or organizations like that, or a manufacturing company, would receive an order, check the credit of the customer, check the customer status, check the inventory. If there's an insufficient supply, either make more product, order more product, ship, and bill. That's how many processes, business processes, order fulfillment processes work. Oh, rats. What I'm going to just go ahead, because what I wanted to do is show you this. That's what I wanted. Okay. So here is an example of how we could diagram a very high level, this high level order fulfillment process. The order is received, the credit is checked, the inventory is checked, the product is checked, shipment happens, billing happens. This is the very high level process. And this is an interesting way to start developing a set of process flows for a system, is to start at this very high level. But this really isn't particularly sufficient. This isn't necessarily sufficient. We can, in our flow diagram, go from a high level to a more detailed level. And so in this, we still have this exact same high-level activities. The order is received, the credit is checked, we check the inventory, etc. But we've added a lot more actions. We've added decisions. We've created process loops, and we can account for time. So in this case, the order is received. The order is entered into the system. The credit is checked, and now we have a decision point. Is the credit good? If it's not good, we're going to refuse the order. If the credit is good, we're going to check the inventory. Then we're going to, when we check the inventory, we're going to have another decision to make. Is the product in inventory? If it's not, we're going to get the materials needed. If it is, we're going to continue. We're going to schedule shipment, confirm the delivery, ship the product, and prepare. So we have one nice linear flow when everything works out well. And if things don't work so well, we're going to go off to the right here. So product is not inventory. We're going to check the materials needed. Do we have the materials in inventory? Yes, we're going to schedule the production. No, we're going to order the materials. When the materials are ordered, we're still going to schedule production based on the time that we assume that we expect the materials to come in, but we're going to have to wait. So we're going to account for some time in here that there's a process. We're also going to contact an external system, this vendor system. We have to order the materials from the vendor. We're going to receive our materials from the vendor, inspect them. Are they good? No, we're going to go up and start it again. This is part of that loop. We're going to go up and start it again. If the materials are good, we're going to make the product. Now, what I didn't say up here is when we've scheduled production, either because we have the material in inventory or we're ordering, we are going to still schedule a shipment and get a confirmation date with our schedule a date with our customers. We're going to continue down. Once all the materials are good, we're going to make the product. We inspect it. Is the product good? Our last decision here. If it's not good, we're going to start again. If it is good, we're going to ship our product. That is a lot of information packed into a small space. This is a very, as I said, effective manner of describing a system. A lot less words, a lot more visual. People can really see it and understand it. One of the biggest, hardest thing for students in my experience to deal with is this idea of a decision. A decision is always in the form of a diamond, and there are a number of other videos that I'm going to go through in great detail about the specifics of each of the kinds of shapes in the flow chart. But the decision comes in a form of a question in a diamond. If we were doing a billing system, is today the billing date for this customer? Yes, we have a couple of answers, right? We have a couple of options for answer. Yes, and we have an arrow showing the flow for yes. We have an arrow showing the flow for no. And we may have a way that we come back to make this decision again, because we might find out that the billing date is going to be on a weekend that we are not processing. So if it's not today's billing date, we may have more logic here that's going to determine if this is close enough to the billing date. So check the date again. At any rate, it doesn't have to be a yes or no answer. It can be what type of bill is this? Is it going to be an online bill? Is it going to be a paper bill? Is it going to be an invoice to a company? There could be all sorts of things that is a decision that changes the flow. If the decision changes the flow, changes the process, we want to document it in our process flows. So the key to a good process flow is to be descriptive with good labels, with using the shapes that convey information, using lines to indicate directionality. It's really helpful to be linear if possible. Crossing lines is really confusing. If someone has to take their finger and trace the line, it's a problem. So if we look back, right, we have one linear flow here, we have another linear flow here, we have another linear flow here, and they interconnect at decision points. This is a really nice model of a flow. Pick a level of detail. Within one flow, we want to stay at a specific level. We don't want to mix them up. It's too confusing people. It's possible to make multiple flows so that each level gets its own flow chart to get clarity, right? So here's that high level one. We would hate to say, if it would be very confusing to have order, get the receipt of the order, check the credit, and then have a bunch of detail about checking the credit. Here, go back to inventory, check production, right? Because there can be a lot of detail with this, but it will not communicate what you want it to do if you have only one of these high-level items, high-level actions having detail, because you would think there's nothing more to the inventory check. It would be so simple, when actually there was quite a lot of detail under the inventory. Pick a level of detail, stick with it within that flow. If you have this kind of a flow, you can have a sub flow, another flow chart for each of these different components. On the Canvas site, there are several other videos that will describe each of the symbols for the flowcharts. It's important to follow those flowchart rules, because each of those symbols conveys information. So let me know if you have questions. Talk to you later.